Hello and welcome everyone. Good morning, good afternoon, good evening, depending on where you are connecting from. Thanks for joining us today in a new episode of Let's Talk About Data Show. In our show, we discuss all the data related topics, including database migrations, modernizations, data analytics, streaming, and of course, generative AI. My name is Ibrahim Imara. I'm a database specialist solutions architect at AWS. I'm based out of London and I'm one of your regular hosts. And for today, we have another interesting show, a topic that's related also to generative AI, but it covers one point that when we worked with our customers who are working on adopting generative AI, we noticed that this topic or this point is being overlooked by our customers, although this point is very critical and might impact the process of adopting generative AI. This topic is the data foundations for generative AI. And I'm glad today to be joined by Martin, Eric, and Kishore to discuss this topic. So let me first open the space for our guests to introduce themselves. Martin, would you like to start?
Yeah. Hi, thanks everyone for joining. My name is Martin Pamakawa. I'm with AWS. I sit on our worldwide data and AI partner go-to-market team where I specialize on our data for GenAI motion. Great to meet everyone.
Thanks a lot, Martin, and to you, Kishore.
Hi guys, good morning, good afternoon, good evening, wherever you are from. This is Kishore Tatawati. I'm based out of New Jersey. I'm also the part of worldwide data and AI partner go-to-market team, focusing on database migrations and modernizations and data foundations. Looking forward to speaking to you guys.
Thanks a lot, Kishore. Last but not least, Eric.
Hello, everybody. Welcome. So my name is Eric Miller. I lead the data and AI practice for ClearScale. We are a premier tier AWS partner, have been for about 11 years. I've been AWS focused for about 15 years and really excited to be here today and appreciate you having me.
Oh, thanks a lot, Eric. And on chat, we have Prasad, our host as well. He will be helping you with any questions that you have. And CrazyDB5 is one of our regular viewers. Hey, how are you doing? Nice topics. Looking forward to the show. Thank you. And he's joining or she's joining from Mumbai. So let us know where you are joining from. And yeah, how's the weather your side? By the way, it's quite warm here in London. So sunny. So yeah, it's actually summer here. I'm not sure about you guys. How's the weather your side?
Cold and gloomy in Washington,
Oh,
D.C.
wow. Okay.
I'm in office, it's kind of shivering. I have to
Oh,
go and look at where the temperature is setting.
sorry for
So
that.
it's humid here in Columbus. We just got a lot of rain followed by a lot of sun, so all that rain is turning into steam. But
Okay.
beautiful.
Okay. Nice. And also we have Curious One to London weather in New Jersey. Okay, that's nice. Perfect. Okay, so back to our topic again. When you shared the topic and the discussion of the topic with us to discuss this in our show, one of the interesting things that you have shared with us is the statistics that have been conducted by Gartner about the companies who are trying to adopt generative AI and about the low transition rate from having a POC or proof of concept to moving to a production product in the generative AI field, and how is that being impacted by the data definition, or the data foundation for generative AI? So let me start by asking about what actually do you mean by the data foundation for generative AI?
Yeah, so that's a great question. So when we talk about data foundations for generative AI, we're talking about everything that really makes the data usable for AI. So that covers infrastructure, governance, processes, quality controls, all that really ensure data is accessible, accurate, and secure. So we're really talking about turning that raw and fragmented data into trusted, high-value business assets. So as most people know, GenAI models are extremely powerful, but they're really only as good as the data you feed it on because they're generic and trained on vast amounts of internet data. So without clean and governed data, even the best models are still going to hallucinate, have biased results, or have outcomes that you simply can't trust for production use cases. So when we talk about data foundations, we're not just talking about the technical requirement of checkboxing a vector database. It's really the critical first unlock for creating the foundation to then scale real-world business outcomes out of your GenAI use cases.
Perfect. And as I was saying, usually even in our conversation with our customers, when we talk about the generative AI, most of the focus from our customers is on the outcome, on the product itself. But sometimes this foundation layer is being overlooked, and hence what you have just mentioned now is that the outcome might not be up to the expectations, and then there might be some kind of a frustration, and hence it just they might even move away from adopting the generative AI, although it's not the problem of the generative AI itself. It's how you are presenting the data, how you are preparing them, as you mentioned. So that will lead me to this next question, which is, what are the risks of not having this data foundation for the generative AI?
Yeah, there's a lot of risks. So I can try covering a few of those, and then perhaps I'll hand it over to Eric to see what he's seeing from some of the customers on his end. But I think you mentioned one of an interesting point, and it was actually from a Gartner study that's reporting that fewer than 10% of generative AI projects are kind of crossing over that key stage from just an experimental project into an actual full production use case. And from our perspective at AWS, working with tens of thousands of customers, this is exactly where we're seeing most of our GenAI projects stall and struggle. So a lot of organizations are starting with these isolated pilots or proof of concepts, and there's a ton of early excitement around those. But again, without that unified, high-quality data, the models are running into hallucinations, bias, compliance risks, et cetera. And one of the key risks there are business leaders are losing trust in those outputs. So, the problem really is rarely the model. It really stems from that data, whether it's missing metadata, inconsistent formats across legacy investments that have been made. So I think the key there is also is that when companies are getting this right, they're seeing a 51% higher return on their actual AI investment. So I think that's one of the key things. If you're just focused on getting to sort of the promised land of that use case without focusing on how to get there in a scalable way, that's where we're seeing a lot of our customers run into issues.
Yeah, nice. And I believe, Eric, this is exactly also what you're seeing as a partner when you are working with the customers as well.
Yeah, that's right. I agree with everything that Martin shared. So, basically, the question that you ask is, when customers or when anybody skips data foundations and goes straight to outcome-focused thinking, what are the risks? And the risks are exactly what we're seeing. We're seeing this sort of, this POC graveyard start to develop on the outskirts of town because all of these projects are getting caught in POC hell, and that's the risk. I think it's interesting to double click on that and say, but why? Why is that happening? Why is GenAI so different than every other technology that we've seen, in the last 10 years, where we could do a POC and then pretty easily take it into production? And I believe that there's at least two things that feed into that outcome, that POC hell or that POC gradient outcome. The first is the subject of this discussion today, and that is skipping the focus on data foundations. The way I like to talk about this is, the problems that customers have with their data, they probably had those problems 2 to 3 years ago when ChatGPT hit the scene and made generative AI a household name. Those problems haven't gone away simply because they have an appetite for Gen AI now, right? What customers don't realize, I think, is that I think there's a misconception that you can simply expose these general purpose super large language models to your business data and get the same kind of outcomes that you can for the general knowledge that Martin talked about, the who won the World Series in 1942, how do I make sourdough bread type type questions, right? You want to see the same type of accuracy on top of their data. And unless the data has been prepared and unless the data has been curated, imagine a company that has we're reasoning on top of their Confluence data, for example, which is a common use case, but that Confluence data is 10 years old, right? And there's actually not only conflicting articles inside the Confluence, new replacing old, but sometimes multiple conflicts, and so then that is engineered hallucination. So that's the first, I think, contributor to the POC help, and that is that there's a non-trivial amount of work that has to be done typically to prepare customers' data footprint to work efficiently and cost effectively with generative AI. The second one that we're pretty opinionated about is this, what I call the engine and car analogy. And that is, large language models or crews of large language models typically don't solve business problems by themselves. But a POC is typically not much more than a large language model or a collection of large language models. We'll use sometimes the CLI or the console or a very lightweight web interface to interact with it. And it's not the kind of thing that you can say, okay, flip a switch and then send that out to all your customers or your employees and start using it, right? And the reason for that is because, if we look at the large language models or the crew of large language models as the engine, there's actually a lot of required components that need to go around that, which I call the car, in order to achieve the outcome of transportation, which is what people want, right? Yeah. So things like, what is the interface for this? We're not going to introduce a new interface. Customers are going to want to use their Slack or their Teams or Chime, or maybe some use cases we use SMS or email, right? That's the interface component. Maybe the interface is automation, right? So batch data triggering events in S3, for example, right? So we have to have, that's the passenger, if you will, right? Then we have the fuel tank, which is the data. And that needs to be swappable from one use case to the next, because typically use cases are data source specific, right? We want to have an HR agent that sits on top of our HR data, et cetera. You raise that to the power of things like role-based access control for data. So ensuring that human users they only have access to data, the models that are working on their behalf only have access to the data that human user would have access to. That's a big engineering problem, right? So the point I'm trying to make is that there is at least a dozen components, a transmission, a gas pedal, a steering wheel, that make this car that sit around a large language model. And there's a non-trivial amount of engineering that go into that. And when a customer starts to think, okay, I saw this outcome in a demo and it looks like it can answer the questions on top of my data, but now to make the jump so it's usable by my employees and my customers in a cost-effective way, they just don't know where to go with that. And they don't know all those components that are required. And if they do, they may or may not be willing to invest in that when they start to do an ROI evaluation of the engineering that's required.
Great. Thanks a lot, Eric. Before moving on, I want to say hi to some of our viewers. So Nightmare Gaming, hi, hey, how are you doing? DTA is saying, I think the way data structure is also very important. I believe we'll be covering that as well, but I agree. Damien is saying hello. Hey, Damien. Data Whisperer, hi all, tuning from UK. Hey, Data Whisperer. And Wild Data Zero, what steps can be taken to avoid bias within the data foundation? I think this is one of the things that we'll be covering, I believe, throughout the session. Okay, perfect. And the schizophrenic web developer, is data same as information? Any thoughts?
I can take that.
Okay.
I mean, I guess it's It's one way, yes, but the thing is that I always start whenever I'm introducing the data warehousing or data, converting the data into the information is the entire key, right? In terms of you may have mountains of the data. How do you convert that as he has mentioned just now, like, how do you convert that into a car which can be used to go from place A to place B, right? It's in the same way, the data as such doesn't mean anything as long as it cannot be actionable, right? So
Mm,
you have the data, like, you should be in a position to use it. Hey, maybe my market share is low. What can I do with that, right? So why is your market share low? Like,
yeah,
as long as it can answer those questions, then the data becomes usable in information. Yeah. We're
perfect.
going to cover more on that, but like, I would leave it at that.
Okay, we'll continue with the commands, but just we need to cover one more part because uh, just back to what you were mentioning. You mentioned a couple of components that can be used for building this strong foundation for for generative AI or the data foundation. So let me ask you, Martin, what are the other foundations that are there, or the components that are there in order to build a data foundation for generative AI?
Yeah. So when we're thinking of what a data foundation looks like, it's really a journey for our end customers that is helping set the foundation to be able to deliver that business value and information from your data, as Kishore mentioned. So one of those starts, and I guess to preface, it's not necessarily linear. So
Hmm.
depending on where you are as an organization, you may already be cloud native, you may be still on-prem. So it's going to be different for each customer, but it starts with helping organizations. So ClearScale help a lot of our customers move off legacy and siloed platforms to help centralize their data ecosystem. So this brings some of that structure and accessibility, some of the unified governance through services like X3, Lake Formations, Glue, Data Zone. From there, you move into the modernization stages. So this is where you can help transform and prepare the data for things like real-time analytics, ML, and GenAI. So this is things like ETL pipelines, leveraging our zero ETL tooling, streaming injection, advanced data preparation through some purpose-built tools we have. And then we have our purpose-built databases like Aurora, DynamoDB, Neptune, which all have vector embedding capabilities. And this is where we sort of bridge from the modernization to being able to serve that data up for generative AI through things like retrieval augmented generation, vector search, et cetera. So really depending on where you are at within that journey, that's sort of dependent on which stage you're at. Eric, it would be great to hear from your perspective what that journey looks like. I'm sure you and the team at ClearScale probably have a much more defined customer journey that you all are using with your end customers.
We do, especially front-loaded at the beginning of the journey. So that's actually our favorite customer to work with, is the customer who's up for the journey, right? They know they want to take the first step. They've got their backpack packed and they've got their eyes set on a hill some distance away, but they don't know how to get there. We typically will do workshops with customers and start off, bring in all the key stakeholders for a half day. And we'll start off with sort of a, nothing off the table, no rules, whiteboarding session to talk about all of the things that they think they could possibly solve with generative AI. And we'll make it easier for them by doing some short enablement to help them understand the difference between typical, an RPA problem or an analytics problem or a hard data science, predictive problem versus generative AI. So they have at least a 100 level understanding and a new set of lenses to look at the business and say, yeah, that's a generative AI problem. We put all these use cases on the board, and then we organize them and say, okay, let's stack rank these based on business value, which the customer decides, technical feasibility, how well it is a fit from the curb as a generative AI use case, and then sort of level of effort and technical LOE, if you will. And then from that conversation, basically what you're looking at is the primordial ooze of a roadmap, right? We'll start with the ones that are fastest, easiest, and bring the most business value, right? And then kind of work our way down using business value as the primary key, if you will, right? And only kind of excluding them if they're, not good fits or, high level of effort. And then I guess the other thing that we do that might be a little different that we've learned from experience to help with the sort of POC POC graveyard thing is we build production ready. We try to build production ready from day zero, meaning all those elements that we know that are going to be required. We don't start with MVP for generative AI specifically, right? We do with other types of projects like migrations and data modernization, IoT, et cetera. But for generative AI, we have a pretty strong opinion to address the same trend that we're talking about today. And that is we build components so that when a customer sees the outcome that they want, then we're ready to go into production, right? We built it from day zero, even though we still had a lot of prompt engineering and model role engineering, et cetera, to do to get the outcome that we wanted. And that's been pretty successful for us. I would say most importantly, that sort of workshopping process where we work backwards from business value. Because again, when we start talking about all the additional engineering and the total cost of ownership, then it becomes not a can it work or how cool is it, but it's an ROI discussion, right? How much will it cost, and what is the actual benefit to the company? So framing it that way has been really successful for us, and our customers seem to enjoy that journey because we've had some repeat travelers, if you will.
Okay, that's great. And for this journey, because sometimes, and I believe you also see this when you are discussing with the customers about the journey of such a journey, and then you start talking about the different services that you'll be using after agreeing on one of the use cases. Sometimes it's a bit confusing because of the too many services are there, and the customers might need just tell me in simple words how to start with this. What are the basic steps to do that, the basic services? So how would you answer something like that if the customer is asking you?
Art, do you want to take a swing at that first, or do you want me to go first?
Yeah, go for it, Eric. Yeah.
Yeah, so it really depends on the customer. We have found that there's really two types of customers, and really more specifically stakeholders at a customer. There are those who are technical, and that's either because they're in a technical role, like a technical leadership role, or they just come from a technical background. And for those customers, obviously, we're going to have a deeper discussion around the architecture and tool justification for each element in an architecture that we would propose. I would say that's for 20% of the conversations that we have. One of the things that I've learned in 15 years of doing this is the more you learn about tech in general, the AWS and cloud native, the more you assume that an AWS customer also knows the things that you know and has the perspective that you do. And what I've learned is it's actually not the case. Many customers, I would say 80%, are just sort of like, we just want to know how much it's going to cost. You guys go do it, and then we want the outcome, and we also want to hold you and AWS accountable for the outcome on an ongoing basis. That's most of our discussion. So it's pretty rare. Again, 20% of the time, we'll have a technical stakeholder that wants to get a little bit of orange underneath their fingernails and talk about the tech stack, and we love doing that. But generally, customers are very happy to say, "Listen, I'm an auto manufacturer. I'm a retailer. I'm a state and local government. I don't want to know about this. I don't care about it. You're confusing me when you say it. So what I want to know is how much does it cost? How can I optimize the cost over time? And how can I ensure that the outcome that you are delivering at the end of the project, you're going to deliver, on day one, month one, year one, et cetera." So it's usually a pretty easy discussion, and the customer trusts us to hold their hand on that journey. But when it's not, we're happy to have that discussion, and it usually ends up in the same spot.
Yeah, totally agree with you. And if you would just want to explain it in like for the technical team in simple terms, like how the data will be migrated, will be streamed from whatever the source and where it will be stored centrally, and how it will be cleansed, and it will be being prepared for the generative AI using the AWS services. What are the main services, AWS services, that would be used for something like that? Martin or Eric?
Kishore, would you want to take this one?
Yeah, sure.
Okay.
From a perspective.
No, this is an excellent question. Thanks, Martin. So I think there is somebody who was also asking the question in terms of like, hey, how do we convert the data into information? How do we do it, right? So if you look at it from the left-hand side to the right-hand side, right, AWS offers multiple services to do the things. But just as Ibrahim rightly pointed out, the important things are, let's say if you do have a structured data, we have data migration service, DMS, which kind of can take the data and it kind of does homogeneous and heterogeneous migration, and it can land you to the S3. And then like, you have a lot of purpose-built services like, uh, genomics, image analysis, health lake, and all those things, extract. These are the things that are mostly for the unstructured data, right? So again, going back to the analysis, let's assume that you have a driver's license or an insurance document. How do you extract that data from that? So the first question that what you need to ask is, hey, what is the type of the data that what I have? Then the important aspect of like, converting this data into the information is you basically cleanse the data and you standardize the data. When you're cleansing and standardizing the data, like, a lot of times what happens is, I'm sure Eric and a lot of you can resonate very well with me here. Nobody gives you the business rules, right? Hey, I'm busy. Why don't you kind of use artificial intelligence or generative AI to figure it out, right?
Yeah.
AWS Glue, and then like the Glue data quality kind of automatically suggests you some of the rules for you. And then your data steward can kind of come and suggest, hey, is this the right thing or not, right? So now you landed the data and then you cleansed and you standardized the data. And then again, depending on where you want to do, if you want to build analytics, you can move to the Redshift. If you wanted to kind of do like, machine learning, you can use the SageMaker. But the important thing that what I wanted to tell you is earlier we heard the feedback from the customer wherein they wanted a single user interface, right? So
Yeah.
you can actually use our SageMaker Unified Studio to do all of these things. You can extract the data, you can catalog the data, you can cleanse the data, you can also do the machine learning on the top of it. And 70% of the use cases, again, I'm opinionated here, are the RAG-based use cases. Most of the times people wanted a vector database. They don't want to create a new vector database. They wanted to use the vector database, which is the part of their operational system.
Yeah.
So AWS offers a lot of services like Aurora, wherein you can co-locate your operational data and also the transactional data. So just to summarize, right, you have S3, you have Glue, you have DMS, and you have SageMaker Unified Studio. Let's stop there, and then we can drill down if you want more. And there are purpose-built services as well.
Sure. We're going to do that, but first let's check the comments in the chat here. Okay, so there was a question from Schizophrenic Web Developer. Do we always need to export the interface? Not sure which interface are you talking about. Yeah, sorry.
I can answer that.
Okay.
I actually was reading that comment and trying to find a way to answer it in chat. But it also feeds into what you were talking about earlier, the question that you just asked about the AWS components. So the short answer to the short direct answer to the question is no. You don't always need to expose the interface. Recall in my long tirade previously, I talked about the two different ways that we typically interface with data. One is a human user providing prompts via some mechanism, right? And the other is via automation, where we'll have, you can imagine exports from a data system, dropping data on S3, and then those events triggering, some sort of inference and reasoning on top of that data. For example, a batch of legal documents, and we're looking for a certain type of sentiment and type inside those legal documents, et cetera. So the short answer is no. You don't always have to expose an interface, and you can even further. You could go further and say, I don't even need to trigger with an event. I could set up a pull automation to pull, so there's actually no interface at all. Where the automation around the large language model, the car again around the engine, is getting its data in a pull fashion. But if you don't mind sharing my screen, I've got a little diagram there that I wanted to share with you guys.
Sure.
When you ask the question, what components are typically used, obviously all the ones that Kishore mentioned, absolutely straight down the fairway. Obviously, Bedrock key service, right? But what the service that I think all the AWS people will be surprised to hear us make a case for, as instrumental and essential for all of our workings around generative AI, is actually Lambda. And of course, it's a Swiss Army knife, so it's not that surprising. But it's usually not the first service to come off somebody's tongue when you start talking about this topic. But when we're using Lambda in at least three really interesting ways. First, it is always the interface that we use for human interfaces, right? So whether we're using Slack or Teams or whatever, it's always going to be processed through Lambda. When we do our change data capture, it's also done like again, this is a Confluence example, but this could be S3, SAP, Salesforce, Google Drive. Name your data source, right? And it could be that, and we either have webhooks or pulling trigger lambdas to then grab the changes and then reindex the vector store, or whatever data store is sitting behind our context server, right? And then the other way that we are using Lambda that's really interesting is with secrets management, right? So again, we want to give these functions the ability to be agentic, right? To go out, and every time I say agentic, I remember who's cringing and saying, "Oh, he had to throw it in," but like we're really doing it, and it's the new normal for us. And so what that means is these things have to have the ability to interact with the outside world in a first-class way, which means we need to save those credentials somewhere in an encrypted format where they can reach out and get them, and then ping an API with those credentials, or log into an email client, or log into a web client and take some action, RPA style actions as a true agentic large language model solution. So we're huge fans. If you took Lambda out of what we build, we couldn't do it, right? Now, again, this is not so much about data foundations. Remember, I said there's two things. It's the skipping data foundations and the car around the engine. This is more car around the engine stuff and not specific to data, but we think it's also really critical too, and huge fan of what Lambda does for us when we're delivering these solutions.
Just regarding this Lambda reference here you mentioned, I'm just curious to know more about, is there like an orchestration layer that handles all of this, or the Lambda function itself on its own being triggered based on events or something like that?
No, so we did a great deal of research into agentic frameworks, and we use AutoGen. And I didn't want to, this is a discussion, so I didn't want to focus too much on things that I want to keep it open. But since you've asked, I will share with you that the orchestration framework that we use is AutoGen. And what we are really proud of is that we built a custom layered Lambda that gives us AutoGen natively in Lambda, keeping in mind that the inference, if you will, doesn't happen when AutoGen or Crew.ai or LangChain or anything. They typically don't sit on the instance that's doing the work, a GPU instance, right? So in this case, we're using Bedrock. So the call goes out to Bedrock from the AutoGen enabled Lambda, then the response comes back from Bedrock. So the point I'm trying to make is that you can do it on a cheap, serverless, affordable Lambda, scale to zero, pay nothing when you're not using it, instead of spinning up EKS or similar. And you can do that because the orchestration engine does not require, it's just a script runner, essentially, a job runner, a task runner. It doesn't need a GPU. So that's why we opted for Lambda to host our AutoGen. It took us about 2 weeks to get it hacked in. We had to mount EFS because put it in a VPC and mount EFS. And I could do a whole show on that, on the engineering challenges that we solved to get an AutoGen enabled Lambda. And I think a lot of people would be interested in it because it was
that will be interesting.
A cool project.
Yeah. Perfect. Thank you so much. Okay, before moving to our demo for today, I just want again to see some of the comments there there's a comment from Azra. Hello, can you explain fine-tuning LLMs and data sources for students if available? I think that we can have like a separate show for this about fine-tuning for large models, and I believe we can check if we have like on AWS Builder if we have a course that covered this, but we can dedicate a show for that. And also the an article or link for the show. I believe Prasad already shared the link for that. So this is the link for all the past shows, including this one. Once we finish it, we will add a link to the show as well. Okay, and then a question. Oh, okay. Yeah, I think that's it for now. Okay, so Kishore, you promised us with the demo for this, so let's see.
Yeah, sure. So I guess I just wanted to take a quick moment to answer that question, right? RAG versus fine tuning. Yes, we should definitely spend an hour on that. But as you are a student, like, and I would put it like this, right? This is a good segue to our demo as well. Think of RAG like is, you're answering some specific question by looking at your notebook, right? And
Mhm.
fine tuning is something like you're training something. You are probably I would like to think of it like you wanted to add a new chapter to the existing book, right?
Mhm.
That's the fine tuning. So having said that, let me just I always have a problem in terms of sharing the screen. Ibrahim, let me know if I'm sharing this correctly or not. Can you
Uh,
see my screen?
it's yes, we can see it. Generative
Uh,
AI for healthcare.
okay, sure. So I wanted to now that we had a very interesting conversation from Martin, Eric, Abraham in terms of why the data foundation is important. So why are we building this data foundation to have some kind of an end product? As somebody was asking, how do I convert this data into the information, right? So
Yeah.
what me and Martin thought was we'll probably take a healthcare and life sciences use case, and we'll also take the popular RAG-based architecture. I mean, good to see that there are a lot of questions on that. And we're using PostgreSQL, one of the most popular open source database with PG vector extension for that. So this is the high level agenda that what we have, right? Basically, I'll start with the problem statement. And then before we jump onto the AWS always wanted to work backwards, right? We just want to show you if you were to build this from the scratch, what are the different components, like the core example that Eric has given, right? What are all the different things that will make it as a core? And then how AWS helps. And then
Mhm.
in the actual demo, I do have a recorded demo. What I wanted to show you is how an user can interact by using the natural language and how can he get answers to based on different therapeutic areas, and how can he apply the filters without really applying the filters, and how do we enforce the responsible AI, and how can I fine tune the recall. I mean, I don't think we have time to do a deep dive on this. At least I wanted to scratch a surface and show you what is out of possible.
Sure.
Okay, so again, this is the problem statement. What we are going to build is the clinical trials bot. If you are new to, I mean, if you are kind of familiar with the life sciences, we all probably know how much time researchers do spend in terms of getting the information about the trials, right? It could be there may be recruiting the new patients for the clinical trial and they wanted to do a lot of research, right?
Mm.
But if you ask a question, right, most of the time, right, why do I even need a bot, right? Because the data is most of the data is unstructured. Again, goes back to a lot. Somebody was asking a question, right, in terms of how do I get this information from unstructured data? So the government collects a lot of clinical trials data, but every time I specify cancer, I specify diabetes by using different means, there is a different source of truths, and it is all embedded in PDFs, in documents, and whatnot, right?
Yeah.
So do we really want researchers to spend time in terms of figuring it out and converting this into information, or can we give them something simple, right? That's why there is a need for the clinical trials bot. Uh, so this is the typical architecture. I'll probably give it 10 seconds for you to go through and look at it. Those who are familiar with the RAG-based architecture probably know this. So if you look at the step number one and step number two, what we are really doing is we're taking the clinical trial data. We'll talk about where we get that from. And then in order for you to provide the semantic search ability, and what do I mean by semantic search ability is you ask a question and the user interface needs to understand the intent behind the question rather than kind of searching based on the actual word to word and then answer. In order to do that, you need to convert the raw data into embeddings. So how do I convert the raw data into the embeddings is what we need to use something called embedding model. So you load all the data into the vectors here. And then when the user asks a specific question, you need to search and get the relevant information from the step number 2. But the data in the vector database is in the form of vectors. So it can only understand the vector language. So you need to convert the question also into the vectors so that you can get the relevant data. Maybe let's say if I'm asking for, hey, show me the information about this particular order, it will get you all the relevant information. And then the original question and then the prompt will get submitted to an LLM, which is what we call it as a enhanced context. Then you will get that personalized response. This is the typical RAG architecture. And again, we can talk probably an hour about this, but the idea of this is not to explain you the RAG, but if you have any questions, do let us know. We can try to answer in that. But
Yeah,
this is in terms of what is the underlying architecture. Yeah, Ibrahim, you have a question?
yeah, so Kishore. Yeah, before moving on, so I believe the data cleansing and standardization that we were talking about that will happen at this step. Yeah, first step between the receiving the data sets and then chunking them and embedding them, right? This is where
Exactly.
I'm going to do all of that. Okay. So based on that, you can have multiple sources as we were discussing, and all these channels can send the data to maybe a central location, maybe an S3 bucket, or whatever the central
Mhm.
location that you are looking for, and there you can work on some sort of like data cleansing or standardization of the formats or something like that before chunking them and vectorizing them, right?
Right. No, you're exactly spot on, Ibrahim. So as I was mentioning earlier, right, we need to understand what kind of the data that what we're bringing it in, and then identify the right tool to do that, right?
Mm,
So in order for us to do all of that, you have to first bring the data to the cloud. The moment when
exactly.
you bring into the data to the cloud, yes, you are right. Between step number 1 to step number 2, there are two things that would happen, right? You need to cleanse and standardize and also convert to the embedding. So what I usually suggest is you don't, once you cleanse the data, you also keep the copy of the raw data so that you don't have to keep cleansing it again. So that you're up, so that from the data lineage standpoint, oh, this is the response you got from the Slack or user interface, and this is the corresponding data that what you have. I'm saying yes to that, but I'm just probably I would have elaborated step 1 and step 2 to include the
Yeah,
standardizers.
but
I will do that next time.
then I was just thinking, is it possible to again use the AI to do this step, the standardization and data cleansing, instead of manually doing it? Not manually, of course, but I mean, can AI help in something like that as well?
Oh, absolutely. I mean, there are two ways to say that, right? One is definitely there is a human element that is involved in it.
Mm,
Right now at AWS, we're how do I say, we're embedding generative AI capabilities as a part of each and every AWS service. So when it comes down to the AWS Glue, we have the AWS Glue data quality rules, which are automatically embedded, wherein it kind of
okay.
suggests you. One of the examples of the standardization is the data cleansing, right? It can
Yeah.
cleanse and suggest the rules, and Kishore goes and looks at it and says that, okay, hey, this looks good. Let me convert that into automatically a glue job, right? So it's not
Yeah.
only suggesting the data quality rule, it is also converting into the data pipeline. And it is also giving an ability to data steward, hey, yes, this is the quality rule I wanted to apply. This is the quality rule I do not want it to apply. We can do
Okay.
all of that end-to-end process.
Great. Thank you.
Right? I can move on to the next one.
Okay. Sure.
So again, this is a loaded slide, but our idea is, hey, we spoke to you conceptually about how all of these things will fit in, right? But what are
Mhm.
all the different AWS services that help you, right? So while this looks little loaded, but it is very easy, and we can also do this by using knowledge bases wherein it will mask you with all the underpinnings of the details. But let me spend probably 30 seconds to 1 minute in giving you a walkthrough of this process, right? Abraham, as you were asking, what we did initially is this
Yeah.
is a government website. I mean, those who are you on live and watching it, you can kind of log into the clinical trials.government, wherein you have the government regulates everybody who's conducting the clinical data set, or most of the clinical data sets has to be recorded over there. I
Mhm.
think at this point in time, you have probably 500,000 trial or study information that what you have. What we did for this is right now, because this is a POC, we have downloaded that and then uploaded that in a compressed format in the S3 bucket, right? And again, while this is not related to the HIPAA, one of the thing Martin and Eric has mentioned is the security is very important service.
Definitely.
Most this is a HIPAA eligible service because this is the question that what we get every time whenever we're asking the
Mhm.
then, if you look at the step number 2 and 3, this is where we're using the SageMaker notebook. Think of it like a code, the one that which I have mentioned as a glue. It does two things, right? It cleanses and standardizes, and it
Mhm.
also converts the raw data into vectors, right? So we are using Titan embedding model in order for you to convert the raw data into the embeddings, we need an embedding model, which is also a foundational model, which is easily available through the Bedrock, right? So because again, all of these things are important for you to know how AWS helps you with the data foundation, right? It gives you the HIPAA eligible services. It gives you automated data cleansing. It gives you an ability by which you can convert the raw data into the embeddings in a cost efficient manner. And
Mhm.
then once you the step number 4 is where basically you have the curated or standardized data, and then you are storing that into the Aurora PostgreSQL.
Mhm.
Again, you're not if you look at it here, you're not kind of buying a new vector database or creating a new instance, and you don't have to worry
Reducing
about
it.
manage exactly.
Mhm. Mhm.
Uh, Martin and myself have a lot of guided learning plans on it. If somebody wants to understand the vector database capabilities on AWS, it will take you from 0 to level 400. And we also have guided learning plans based on a specific industry. I mean, one of us will share it in the chart once this is done, right?
Sure.
So now we have loaded the initial data into the Aurora PostgreSQL. Now the next thing is now we're using the user is asking a question. Here we are using a React API, React, an app that is built based on the React. It does
Mhm.
not have to be, as one of the user was asking, who don't have to use the app. I mean, if they're using, like Eric was showing in his earlier slide, you can use maybe if they wanted to interact with an existing Slack or Teams, we can do that as well, right? Uh, it all depends on what the end user wants, right? And while it is not being shown clearly here, you're showing the Lambda function here. Eric has explained very good job in terms of the important role what the Lambda plays, right? It basically calls the Bedrock API, converts the question into the vector, and then the rest of the magic happens, right? So the intention of this slide is to show you how easy it is to do end to end. What are all the different AWS services that what we have, and how it helps with you in meeting the compliance.
Mhm.
Also, do look up Amazon Bedrock for knowledge bases. You don't even have to know any of these things. With the few clicks, you will be able to build a RAG-based application end to end. I know there are some people who are venturing into the generative AI who had asked that question in terms of how do I get myself up to the speed on
Yeah.
generative AI or RAG or fine tuning. I would highly recommend them to take a look at that. So without further ado, right, like we did establish the fact that the researchers need an easy way to find the answers. And the source here is the clinical trials start government. The
Yeah.
target is the PG vector.
Mhm.
Okay. And I told you that we are converting the data into the embeddings and things like that, right?
Yes.
So one of the things that what we need to understand is we have used HNSW as an indexing method. Let me start playing this, then probably it's easier for me to explain.
Just wanted to let you know that we have almost 7 minutes left in the show.
Yeah,
So,
sure. So this is an important thing. Let me spend a moment to understand this. As you can see here, we have loaded close to 500,000 clinical trial records,
okay.
and we have used this embedding model here. This is an important thing for somebody who's venturing into the new thing. This is
Hmm.
an embedding model that can be accessed through the Amazon Bedrock.
Okay.
And and then whenever you are creating a new vector database, it will ask you what type of indexing that what you need to use. It's kind of think of it like creating a smart shortcuts.
Hmm.
Each vector offers two indexing methods, HNSW and IVF flat.
Yeah.
HNSW is the most popular one. And one other question that what we technical people always get is, hey, how do I get my best recall? What do I mean by recall, right? Okay, I'm asking a question. How do I make sure that it is not hallucinating and it
Yeah.
is giving me the relevant results, right? So there are several parameters that will work, right? That which you may have to adjust to get the right recall. But when we are working with our service team and engineering team, 70 to 80 percentage of the time, the default parameters do work very well. So that
Mm.
is nothing but the M equal to 16 and EF construction equal to 64. If you wanted a better recall and wanted to kind of compromise a little bit on the uh,
Performance.
what do you call latency, you can
Mhm.
also go ahead and increase it to the 256, right? Now
Okay.
I'll show you. I'll ask you questions and see how you get the results back, right?
Yeah.
So let's take a look at it, right? So this is the vector similarity search for the clinical trials. As I was mentioning, it is doing the similarity search, and we're showing you what is the there are 1536 dimensions. Every embedding model will have X number of dimensions that it can support. That is
Yeah.
also an important design decisions that what you need to do. And this is something that which we have shown here because a lot of times if the users are new, they may wanted to tune it, they may wanted to understand. It is always a good idea to show what each of these parameters are. And the distance metric is another metric which will help you to get the right results that what you wanted it. And EF search is another parameter. It's in terms of hey, how many vectors that you wanted me to search before I display the result. So
Mm.
now I'm asking a specific question about a heart failure,
Mm.
right? So what are the risk factors associated to heart failure? As you can see here, I'm giving you a breakup of in terms of how long it took. But the important thing that you need to note is it took only 7 milliseconds. And I'm showing you from the responsible AI standpoint, where is the source? And if you can see, it is all related to the heart failure and the distance score, right? The distance score is an important metric. Let me just pass there here or there here, right? So if you can see it here, it is coming from this will give you confidence to the researcher, right? Saying that it is not hallucinating. It is really coming from the government website. And based on the description, you can see that this is related to the heart disease. And
Mhm.
then the distance score is for those of you again who are new to the vectors, it will tell you how closely we are related, right? So you're asking a question about the heart diseases. So the distance score here is 37. The lower the distance score, which means that it has got the higher relevance or higher accuracy, right? So this is another important thing that what we all need to remember. And it has got the data from the survey that was done from Norway, right? So we have asked them to display the first five records, right? So now when you go down, you're also getting the results from a different country, which is Thailand here, right?
Mm.
Now, which shows the diversity. Now I'm going to ask a slightly different question about the diabetic, right? It's a different therapeutic area. I wanted to show you saying that, okay, Now it took 8.6 milliseconds, right?
Mm.
And if you remember this glycemic index, now I'll show you the clinical trials data and show you this, right?
Yeah.
So the distance is 50. It is a little more than that, but that's the best at what it could do. It gave you the data related to type 1 diabetic, type 2 diabetic, right? So again, let me just pause here. The point what I wanted to say here is you did not apply any filters here. You did not say type 1 or type 2. That is the power of semantic search, right? It automatically was able to retrieve and get the information that what you need. Now you might be wondering, okay, hey, is it really coming from that, or did Kishore hard code something, right? Now
Mhm.
let's open this and see. If you look at it, it's the glycemic control. I know we might have gone a little fast, but that's exactly that what we have seen here. If you see the text here,
Yeah.
okay. So that is from the responsible AI standpoint. You're saying something, Ibrahim?
Yeah, I was saying that gives confidence to the users that it's actually coming from these documents and
Yeah,
making sure that, yeah, okay.
right. So again, my idea here is to show you saying that what is the distance score and things like that.
Yeah.
So what I wanted the users to see is, right, when you're displaying the user interface to the end users, you can pick and choose what are these components that you wanted to show it to the end users. You can also give them a feedback loop saying that, okay, hey, do you agree with this answer or not? Those are the ways by which you can improve the accuracy of it, right? My idea is to show you what is the art of possible, how do we improve the confidence, and how you can ask varied questions. Right now I'm asking a question about the COVID, and it gave you the answers and it gave you the responses. Now I can also ask you, hey, show me the symptoms of the COVID in pregnant ladies, right?
Yeah.
Now it took 5.6 milliseconds. All of these things are you're getting the results in terms of milliseconds, right?
Perfect.
Not which is huge for 500,000 records.
Definitely.
Right. Right.
Yeah, totally agree with you. So yeah, Kishore, that's really fascinating. It's the short time to get all the details that we are asking about from this massive amount of documents that you're using. This is really it's a breakthrough, especially in the clinical trials and getting instant information from multiple documents at the same time. So that's really great. Uh, we have reached the end of our show for today. I would really thank you so much for contributions. Thanks a lot for the discussion. It was really a pleasure having you with us today. And yeah, definitely, if we have any other interesting topics like that, we would love to have you over again. So thank you so much for your time, and thanks for our viewers as well. And yeah, for our viewers, next week, Monday, same time, we'll be seeing you as well with a new topic. So thanks everyone, and thanks for our viewers, and see you next week. Thank you.
Thank you, guys.
Thanks.